Okay, in question 8 is a bouncing ball type of question, right? So a tennis ball is dropped vertically onto a horizontal table. So for this question, the tennis ball is dropping vertically, and then it should also rise up vertically, right? So, but in terms of the diagram, we do it in this way so that we can show you the interval, right? Because the question actually involves the time interval between one particular bounce and the next bounce. Okay, so further information is that the time interval between any bounce and the next one is 90% of the time interval between that particular bounce and its preceding bounce. So that means if the interval between the first bounce and the second bounce, as what you see in the diagram, this is 2 seconds. So between the second bounce and the third bounce will be 90% of that 2 seconds. Okay, alright. So you can continue drawing the diagram until the nth bounce. So in short, the diagram should look like that. So this 1, 2, 3, n plus 1, right, is the number of times the ball is bouncing. So the first one is here, second, third, and this is the nth bounce, this is the n plus 1 bounce. Okay, alright, so in part 1, what are we supposed to find? Okay, part 1, we are given the interval between the nth and the n plus 1 bounce is the first interval that is less than 0.02 seconds. So the interval between the nth and the nth bounce is actually less than 0.02 seconds. We're supposed to find n. So that means we need to find a representation of this interval, the time duration. What is that expression? So you can see the expression here. I've already written it, this one, but how do we actually come up with this expression? Okay, so we look at the pattern. So according to the question, between the first and the second is 2 seconds. All right, between the second and the third one is 90% of that. So it will continue. All right, so looking at the pattern, if this is 2 times 0.9 power of 2 minus 1. So we should expect that the next part here from the third to the fourth one should be, if let's say there's a fourth one over here, right, then we would expect that the interval here is actually 2 times 0.9 squared. All right, so therefore between the 9 and the n plus 1 bound, it should be 2 times 0.9 power of n minus 1 just by looking at the pattern for the first few. Okay, so then we can come up with a formula for Tn. All right, so because we know that this is a GP, all right, first term A equals to 2, R equals to 0.9, so therefore we can come up with this formula. Now, very important, we need to know what is Tn. Okay, so Tn is actually the time interval after the nth bounce. Okay, so this is the nth bounce. So Tn, this expression over here, which is this, all right, is the time interval after the nth bounce. Okay, so we must be very clear about that. Okay, so according to the question, the time interval between the nth and the n plus 1 bound must be, according to the question, is less than 0.2 seconds. So we put it as less than 0.2 seconds. All right, then we solve, then the value of n is actually 45. So this is the answer for this part. Okay, now in the second part, the question actually says find the total time taken, all right, from the first to the nth bound, solve in part 1. Okay, so first to the nth bound, solve in part 1. So part 1 we solve n equals to 45, right? So basically what we are looking at is actually the sum of all these intervals until here. Okay, so up to 44, n equals to 44 bounds, go on to almost reaching to the 45th bounds. Okay, so so if you want to use the formula for GP, right? So the formula is Sn, right? So what is actually Sn? We also need to be very clear. Sn is the sum of all intervals until after the nth bound. Okay, so that means I'm going to sum this plus this plus this plus this all the way until this interval here, until after the nth bound. So including of this, so it will be T1, T2. This is T1, T2, T3, T4, and all the way until Tn. Okay, so if we were to list this one out, okay, it's very obvious that this is a sum of a GP. Okay, so therefore we can actually use this formula. So the first term is 2, common ratio is 0.9. Okay, so that's why we use first term is 2, common ratio is 0.9. Now, this n here, right, quite a number of students will mistake that this is actually 45. Okay, but in fact, when n equals to 45 solved in part 1, okay, so we are actually wanting to reach up to this point only. So you want to reach up to this point, right? So that means this 45, right, is actually n plus 1. This 45 this 45 over here is actually n plus 1. So that means, right, if we want to use a formula as n, the n must be equals to 44. Okay, so by right it should be S44. Okay, not S45. Now, I know some of you, when you do S45 and S44, the answer is still the same. The reason is the interval between the T44 and T45 is so negligible. Okay, let's look at question 9, part 1. All right. Now, question 9, part 1 is quite straightforward. So, 1st January, $10 was saved, right? So, consequently, $3 is added to it. So 1st January $10, so that means 1st February will be $13, and then 1st March will be $16. Right? So N is the number of months counting from 1st January. All right, the month of January is considered to be N equals to 1, the month of February N equals to 2, all right, and so on and so forth. Okay, so starts from 2009, right? January, February, all the way until December. Okay, right. So based on what we have written here, so it is obvious that this is a AP. All right. So the common difference is 3. Okay. So the question actually asks us to find think the least number of years so that the savings would have exceeded $2,000. Okay, so that means the sum to the end terms must exceed $2,000. So I think this one is quite straightforward. Okay, so the only thing that I would like to press upon is how do you solve this quadratic inequality. We've already discussed this before. Need to use the graph, or if you want to use number line, you can go ahead. All right, but based on the graph, it's quite easy that your n must be bigger than 33.79. This one, because n is negative, we reject. Okay, so the least value of n to such that the sum of the savings can total up above $2,000 will be 34 years. That will be exactly 2 years, 10 months, and therefore the date that we are looking for will be 1st October 2011. Okay, so you do not to calculate, this is for you to calculate by the month. Okay, so I think 9 part 1 is quite straightforward. Now, in 9 part 2, the first one, they asked us to find the compound interest earned after 24 months. That means 2 years, 2 years, okay? So I think some of you actually remember a formula from secondary school. Now, my advice is you can remember the formula, but I think it is also good to actually derive, okay? So what is the compound interest on the principal amount that was put in? So the principal amount for 9 part 2A is that, okay, the person actually put in $10 first in the first month. Okay, so we are interested in the compound interest. That means we are interested in the total amount that we get from the interest acting on this principal $10 that we put in earlier on. Okay, so the first month we have $10. So at the end of the month it will be 0.02 percent of that $10. Okay, so simplify that. Now, the thing about financial AP/GP question, right? When the question say 2%, right, you must always see something like this number 1.02. If the question say 5% interest, then you should see 105. So no matter what, you must try to get this 1.02. Okay. So from here, how do I get 1.02? You can factor out the 10, all right, because there is a common factor 10 and 10, right? So when you take out the 10, it will be 1 plus 0.02, so that's where you get 1.02. And this is for month number 1. Okay, month number 2. So month number 2, you will inherit whatever that you got from the previous month, so you will have exactly days. But at the end of month number 2, right, you will be incurring interest on that original amount at the beginning of the month. So it's 0.02 of that amount. Okay. Now, rule number 1, do not go and expand now and evaluate because we want to see pattern. So again, we need to see 1.02. So same trick again. You know that this is a common factor. You can take it out, right? So you take it out, you get this. So you realize it's still 1 plus 0.02. So you can see the 1.02 coming out. And then now you can see the pattern already. Why? Because this 1.02 multiply in, you have 1.02 squared. Okay, so month number 1 is 1.02 times 10. Month number 2 is 1.02 squared times 10. Now I think you can see the pattern already. If I ask you to write down month number 3, what would it be? Right? So it would be 1.02 power of 3 times 10. So for a general n number of months after the initial $10 in the first month, all right, so the total amount that you will actually get from incurring with the interest on that original 10 will be given by this expression. Okay, so because we want to find that interest only, compounded interest, basically you want to take that amount for n equals to 24 months minus the initial $10 to arrive to this answer. Okay, so this will be our final answer for the compounded interest on the original $10 that we put in. Alright, so for question 9, you must not fail to actually come out with this derivation because it is something that you need to start from scratch so that you can actually produce this component over here clearly. Alright. Okay. Now we go to 9 part 2. 9 part 2, we are looking at the total amount of saving. Okay. After n months. Okay, so now we are not looking at only the interest from the original $10. We want to look at the total amount of money saved in the account after n months.
Alright, so let's show how we can actually obtain the sum of the savings after n months, okay, which is this series. So how come we can come up with this series and therefore use the GP formula to finalize the answer, alright, after 24 months, that is 2 years, alright. So we need to show working for this part here. Okay, so the working is like this, huh? Alright, so we form a table. So this is the end month at the beginning of the month and at the end of the month. Alright, so month number 1, at the beginning of the month we put in $10. So at the end of the month, right, we would have $10 plus 0.02 times 10. So this is the interest on that initial $10. Alright, so we can try to factorize this out. So 10 is a common factor, so when we take out, we actually have 1.02 times 10. Okay, now this is a important form of the number that we want to get. Okay, we don't want to evaluate this because we want to be able to see the pattern. Okay, so in the next month, right, we would actually have this amount that we obtained from last month, but every month we put in $10. Okay, so the new amount will be at the beginning of the month will be what we got from the end of the last month plus another $10. Okay, so at the end of the month, all right, then we would have this same amount, but again the same thing, we have a 2% interest of that amount. Okay, so same trick again. So what we can do is we can factorize this out. So when we factorize these terms out, okay, then we will still have the 1.02. Okay, now we start to see the pattern already. Okay, so we realize this one, when I multiply it in, right, I will have 1.02 squared plus 1.02, and because 10 is a common factor, so we take it out. Okay, so you see that. So for the nth month, right, you can then now generalize. Alright, so if this is a second month, I see a 2. So in the third month, I would see 10 bracket 1.02 cube plus 1.02 squared plus 1.02. So n month, right, then I would see 1.02 power of n all the way until 1.02. So that actually explains, right, why we actually have this series here. So now that we have established this series because of this, right, alright, then now we can use the GP formula. Okay, so the first term in this case is for this case is 1.02. So r power of n, so the common ratio is still 1.02 minus 1 divided by 1.02 minus 1, so they can get this value. Alright, so this part need to be shown, alright, so that you can show that actually the sum of the savings after n months is actually indeed this given by this series. Okay, now for part C, because the question asks us to find uh, the number of months in order for us to actually accumulate the savings to exceed $2,000. Okay, so instead of using we use the same formula. Alright, so we take this formula and then put inside here bigger than 2,000. Okay, alright, so then we need to find this n. So solving the inequality, when you reach here, you apply ln. So when you apply ln, in this case the sign is still the same, because ln 1.02 is a positive number, so you realize your n is bigger than 80.48. So therefore we can then conclude the account will first exceed 2,000 after 81 complete months. Okay, alright, from this inequality.